Hey kids, Flexing Teacher Weber here. I have the second video on algebraic patterns I want to look at. The last time we looked at a pattern made of tables and chairs from pattern blocks. Now I want to look at a pattern that's a pattern not so much of a picture, but a pattern involving some money and numbers. So back in the 90s, there was a pizza place called Mr. Bones in Winnipeg, and Mr. Bones Pizza in this problem sells medium pizzas for $9 plus $2 for each additional topping. We're going to make a table of values for medium pizzas that compares toppings and cost. So, our table of values, with 0 toppings except for the cheese, this pizza costs $9. And if you add on 1 topping, it costs $9 plus $2 times the number of toppings. In this case, that's 1. That's going to be $11. Okay, and if you get a 2-topping medium pizza, that's going to be $9 for the original pizza plus 2 times the number of toppings, which is 2. And that's going to be $13 for that pizza. And if you buy a medium pizza for $9 and you get 3 toppings, that's going to be 2 times the number of toppings, which is 3, and that's going to be $15. Okay. So that's our information for Mr. Bones. I would recommend probably making your own pizza and avoiding Mr. Bones, even though it was good pizza. I don't want to criticize the good people at Mr. Bones out there if there are any still left. So I should take that back. My job is not to be a critic. My job is to teach. Now let's look at some of the patterns in here. So you can see each time the cost increases by 2, right? Notice how that connects, and increases here from $9 to 2. Notice how that connects to the idea that we take the number of toppings and we multiply by 2 every time. So we have our algebra here. We're always taking the number of toppings and we're always timesing by 2 and then adding on the cost of the most basic pizza, and that will give us the total cost. In this case, $11. All right? And that pattern continues. Number of toppings times $2 per topping plus $9 for the original pizza equals $13. 3 toppings times $2 per topping plus $9 for the original pizza equals $15. Right, there's our algebraic equation. We're always taking the toppings times 2 and adding 9 on. Our independent variable, is the x. That's the one we change ourselves. And then we change that, the dependent variable is the y. So we could call this the independent variable and this the dependent variable. Okay? The constant is the 9. It always is $9 to get a basic pizza. Okay, now the next thing we want to do is write this algebraic equation in proper form. Well, there's 2 ways we can write it. We can write it as an expression and an equation. Well, the expression, it's 2 times the number of toppings. The toppings are x, and it's $2 per topping. We write that part as 2x. Then we add on the 9, the cost of the original pizza, and there's our algebraic expression. The equation is toppings, which is x, times 2 plus $9 for the original pizza equals y, which is the total cost of your pizza. Or you could write it as 9 plus 2x equals y. Or you could write it as y equals 9 plus 2x. Or you could write it, my favorite way, y equals 2x plus 9. There's your expression and your equation. We're going to use this equation to figure out the cost of a medium pizza with 8 toppings. So we're given that x is 8. That's the independent variable. The equation we just figured out is y equals 2x plus 9. We substitute 8 in for x. So 2, and this is 2 multiplied by 8, plus 9. We follow order of operations. Y equals 16 plus 9. An 8-topping pizza from Mr. Bones. All the toppings are just going to slide off. Can't get 8 toppings on a Mr. Bones pizza. Y is equal to 25 toppings. $25, pardon me. You'd probably be better off to order fewer toppings and get a couple pizzas, in my opinion. So that's how we use substitution to find other costs of other pizzas. Now the next thing we want to do is write 5 ordered pairs and graph this relation. Well, remember, an ordered pair is a point on a graph. We have an x and a y value. Now, we get this from the table. When x is 1, I forget about 0. X is 0, y is 9. X is 1, y is 11. X is 2, y is 13. X is 3, y is 15. So let's write these values as ordered pairs or points in a graph. So 0, 9, 1, and I'm drawing a blank. What was our y value? 1 and 11. Okay, now I'll remember. 2 and 13. 3 and 15. We also found when x was 8, y was 25. We also found that point as well, right? Okay, our graph. We have our x-axis, which we're going to call toppings. And our y-axis, which we will call cost. Okay. Where they meet is the origin. So we're going to start there at 0. Our toppings just went up by 1, and I screwed this up last time. We'll go 1, 2, 3, 4, 5, 6, 7. Now I didn't show you this last time, but we have to start the graph here in the positive area, because if we go here, that's -1, -2, -3, and so on. You can't have negative toppings on a pizza. Okay, we'll have to put some thought into the y-axis. I didn't show you this last time, but a lot of people would do this. They see their y values are 9, 11, 13, 15, 25. So they do this. They go, it's easy. I'll say, okay, this is 9. This is 11. This is 13. And this is 15. Easy. But look at this. I've said this distance is 9. You can't say the exact same distance is now 2. You've got to go up at a consistent rate. So maybe let's go up by 3s. Oh man, I don't have my graph 2 different colors here. I'm going to erase this. There we go. We'll use blue. Okay, so I'm going to go 3, 6, 9, 12, 15, 18. That should be good. I forgot to name my graph. We'll call this Mr. Bones. Okay. So, when we had 0 toppings on our pizza, that pizza was $9. We put a point right there, call it 0, 9. When we had 1 topping, that was 11. So 1 topping is going to be just a little bit below the 12 there. Okay, when we had 2 toppings, that was 13. So 2 toppings, it's going to be up just a little above, okay, let's see, 12, 13 and a half. So 13 would probably be right about, okay, 12, 13 and a half is the midway point. So yeah, it's going to be a little bit lower. So 2 and 13. It's going to go right about there. Call that 2 and 13. And then our last point is 3 and 15. So we go across 3 and up to 15. And there's our last point right there. Call that 315. Oh, I forgot my parentheses there. And you can see we get another straight line graph. We get another linear relationship. Now, would I join these points? If you join them, you're saying there's data on every part of this graph. And I know you can order pizzas with half toppings and stuff, but typically you'd order full toppings. So I don't know if we would join those points. But we would say that this is the graph of y equals 2x plus 9. And this is a linear relation. So look at all the ways we did this algebra equation. Or we started off way back here with some numbers. We figured out the patterns. We represented them as an expression in an equation. We used that equation to figure out more data. We could represent that data as points in a graph, and we could represent that graph as a linear relationship. So hopefully you're making all these connections with algebra, and you'll use this video to help you with your assignment today. That's all for now. Flexing Teacher Weber, out.